All right, the next thing we want to look at is how can we actually find the size of angles inside of right angle triangles. Again, Pythagorean theorem only ever dealt with side lengths, right? A squared plus b squared gave me c squared, but we never knew how big these angles actually were inside. Today's tool will allow us to do that. So example 3 asks us to find the value of angle A, which is this one here, I'll make it red, and angle B. And can we do that for this triangle? Well, yes, because it's a right angle triangle, so we know that tangent is a possibility. But we have to be given opposite and adjacent values for any angle to find out how big it is. And look at that, we are given them. Let's begin with angle A. So I know that the tangent of angle A, and I can just write it like this, is equal to its opposite length divided by its adjacent length. So its opposite side length is 3 meters, and its adjacent side length is 1. That means that the tangent ratio for angle A has a value of 3. Now the problem I'm running into is I would actually like to know how big is this angle A. And what's getting in the way is this tangent piece. So is there a mathematical operation that could cancel out tangent? Well, there is. And it's called inverse tangent, and it looks like this. What we're going to do is we're going to write it down on both sides of the equation, because as you know, any operation you apply to one side of an equation, you must also apply to the other side so that things stay in balance. So these are opposite processes. We haven't talked about negative exponents yet, but this actually just means divide by tan. It's another way of communicating it. We'll come to negative exponents eventually at some point. So how does this work on our calculator? Well, first of all, I intentionally put this here so that these disappear and I'm going to be left with angle A. So how do you use inverse tangent on your calculator? Well, I'll show you using both types. Okay, so the first type where you can see what you're pressing in. You found your tangent button earlier. If you look right above it, you should see tan to the negative 1. So if I want to enact that function on that button, I'm going to push shift. Shift allows me to use a button in 2 different ways. It will do what I tell it to if I just push it like this. It'll tell me on the face what it's doing. But if I want to do what's above it, I push shift first. So I have a little thing up here that says I've activated the shift button. And then I'm going to push tan, and look, it says tan to the negative 1 instead of just plain tan. I can then put in a value of 3. On my calculator, I don't have to close the bracket, but on yours you might. I will this time to show you. And when we hit equals, it says that this angle is, and we'll round it to a decimal place, 71.6 degrees. Cool. Kind of makes sense because this is a pretty long side. This is a pretty short side. I know it's not to scale, but that means this angle should be bigger than this one. And it has to be less than 90 because we're inside a triangle, so that's a very reasonable value. Now for those of you who have the other type of calculator where you can't see what you're pressing in, I'll use my iPhone to show you. Again, you're going to have to punch it in backwards. You're going to have to do 3. And then I want to make this into inverse tan. So I need to use the shift button on it. So if I do, gosh, how do I do that on this one? I think I have to do second function. There it is. Now it's made it into inverse tan instead of just tangent. Look, I get the same answer as the other calculator did. Okay, so it's super awesome important in this unit that you find a calculator that has no Wi-Fi attachments and you start learning where all these buttons are for your specific calculator, because calculators vary a little bit in terms of where you find them and you don't want to waste time trying to create that kind of muscle memory. Let's do it right off the bat. Okay, now we were successfully able to find how big angle A is. Can we also find how big angle B is? You bet we can. So same idea, let's create a relationship between angle B and its opposite and adjacent side lengths. So this time the tangent ratio of B is going to be equal to its opposite, which has a value of 1, divided by its adjacent, which has a value of 3. In other words, the tangent ratio of angle B is going to be 0.3 repeater, right? Your calculator is going to have a whole bunch of 3's after it. Keep all those 3's in there. Don't just write 0.3 because that's a better way of communicating it. Now again, if I want to solve for angle B, I have to get rid of this tan function. How do I do that? Using its opposite operation, which is inverse tangent or dividing by tangent. So if I do inverse tangent on both sides of the equation, and notice I always write it at the beginning, not after any numbers. Okay, it comes first, always. And I'll put number 3 there in brackets. That will enable these to cancel out such that I'm just left with angle B. So I can solve for the value of angle B by taking the inverse tangent of the number 3. So again, to punch that in, I'm going to have to do second function tangent to get the inverse tan function to come up. And then I can put, oh sorry, not 3, it's 1/3. My bad. Let's fix that up. And I can actually put in here 1 divided by 3 so that I keep all those decimals. And it says that the angle should be about 18.43 degrees. I'm going to say 18.4. We'll round to 1 decimal place for angles unless I tell you otherwise. We'll make that our standard. Now, same thing you can do with your other calculator too, just as a refresher. If yours doesn't display, you have to punch in this piece first. You have to punch in the ratio 1 divided by 3. So I'm going to do that. I'm going to hit equals so that that value is in the calculator. And then I'm going to take the inverse tangent. I've got my second function button already engaged. And look, I get 10.4, the exact same value as I do with the other type of calculator. Now, does this all make sense? Well, there is a way we could check. We know that all 3 angles in a triangle should add up to 180 degrees. So do they? Well, I've got my 90-degree angle, and I've got my 71.6 degree angle, and I've got my 18.4 degree angle. Well, if you add all of those up, either in your head or with your calculator, lo and behold, you should get 180 degrees. And therefore, you know that you've done things correctly. All right, one final example of how the tangent relationship can be useful for finding out other aspects of triangles too. Let's go to example 4. Example 4, the first one says, let's find the value of a side length. We've called it x. We've got a right angle. That has to be present to use tangent. We've got a 21-degree angle here and a side length of 8.3 centimeters. Okay? Can we find the length of x? Well, overall, we have to remember again that the big idea of today's lesson is that the tangent ratio of an angle is equal to its opposite side length divided by its adjacent side length. And so within this equation, we actually have 3 unknowns. We have an angle, a length, and a length. And as long as we know any 2 of those, we can find the third one. Okay? So examining this scenario, I have an angle here. That's this piece. I have its opposite side length. That's this one right here. And I have its adjacent side length. That's this one here. So I know the black one, I know this one, and I know this one, which means I'm going to be solving for this one. So let's sub in everything else except for opposite. So we can say that the tangent of 21 degrees is equal to, we're going to let the opposite be designated as x, and the adjacent be 8.3. So what's preventing x from being here by itself? Well, it's being divided by 8.3. How do I get rid of that? I'm going to use the opposite operation, which is to multiply by 8.3. Now, whatever I do to one side, I have to do the other. So that I can minimize the amount of writing that I do, I can actually put the 8.3 out here. And when it's written in this notation, it implies 8.3 times the tangent of 21. Well, that's great because now I can go straight to my calculator and I can punch in those things. I'll use this one since most of you have this type. So I can go 8.3, and some calculators might let you go straight to just putting tan there without a times. Play with yours and see if it does. And I get 3.1. Mine allows me to do it. If yours doesn't, then you'll have to put it in. Now, it says to do the side length to 2 decimal places. I'm going to have to round, so I'm going to put approximately equals 2. And I'm going to go 3.1. This was an 8, but there's a 6 next to it, so that's going to make it a 9. And I'll put a unit of measurement, which is centimeters, because that's the unit of measurement for this triangle. Well, there you go. Let's try one more final example. Here's our right angle triangle. Check. That has to be present for us to use tangent. And here are the other givens. Again, we're being asked to find a side length this time. If we go back up to our original equation, as long as we know 2 of these things, either a side and an angle or 2 sides, we can solve for the missing one. So let's set this up. Our angle featured here is 75 degrees, so we can write tangent of 75 equals its opposite side length is 40, and the adjacent side length is x. All right, so what's preventing us from solving with x? To be honest, a whole lot of things. When x is in the denominator, we have to be very, very careful because it's not the same as just dividing by 40. We're going to be left with 1 over x, not just x. So I want to introduce to you something called the Gerber flip. And it's not rocket science, and it's really not my idea, but it's really, really useful in this scenario. What we can do to an equation, as long as we do it to both sides simultaneously, is we can invert numerator and denominator. Okay? We're kind of used to this idea from doing reciprocal slopes in our previous unit. But if we do that for both of these, let's recognize that tan 75 is actually, can be thought of as being divided by 1. So if we flip it upside down, we get 1 over tan 75 is equal to x over 40. Well, this is really great because now our variable that we're trying to solve for is in the numerator, exactly where we want it to be. So what's preventing it from being by itself? Well, it's being divided by 40. What can we do to get rid of that? We can multiply both sides by 40. Now the other reason I really like the Gerber flip is that I can take this 1 and make it into a 1 times 40 by just writing it as a 40 pretty easily. This is now what I need to put into my calculator to solve for x. So x is going to be equal to, and I'll show you on the calculator, it's going to be 40 divided by tan 75. And I'll do it on the other calculator too so you can see. And we get, my calculator gives me this crazy thing, but I have a button here that can switch it into a normal looking number. Here we go. It's equal to 10.7, and we're going to 2 decimal places, so this is going to round up to a 2, and I'll make this approximate, and the units on that triangle were centimeters. Okay, and just quickly to show you on the other type of calculator, if that's the type that you have, I would do 40 divided by 75 tan. But then I have to hit equals because that's just displaying the tangent of 75 for me. Then I get 10.72, which is the exact same answer. So there you go. Have some fun playing with your first primary trig ratio. Our next lesson is going to focus on the remaining 2. And of all the trigonometry you're going to use, this stuff is so amazing. It's great for the trades. It's great for everyday life. I hope you dive right in and enjoy it. Chat with you soon.